plug it all in?
Yeah.
Yeah, I'll go through it with you. We're gonna plug it in together. And this one's actually easy. They factored it for you, so I think they did the hardest part already. So here's your rational expression. They went ahead and factored it. So non-canceling factors in the denominator. Well, first let's go ahead and cancel out, or at least just put a line through the canceling or removable factors. So that means the non-canceling factor in the denominator would be x plus 2. So set it equal to 0, solve it, and get x equals -2. Non-canceling factor in the numerator, that's going to be -2x plus 3. Set it equal to 0 and solve it. Canceling factor in the numerator and denominator, that'd be x plus 1. Set it equal to 0 and solve it. Quotient of the constant terms. So that's just the two terms that don't have anything on them at the end. 3 over 2. And that's what they want you to usually leave it as, 3 over 2. Which would be 1.5, but I'm just going to leave it as 3 over 2. Okay. So this is the graph of this equation. When the equation has a factor in the denominator that does not cancel out, what is it when it doesn't cancel? When it's non-removable?
It's the horizontal. Vertical.
Infinite.
Vertical asymptote, very good. It is infinite. Vertical asymptote. If the equation has a factor in the numerator that doesn't cancel out, what is that?
0.
That's a 0. You could call it a root also, a 0 or a root or a solution, all the same thing. When the equation has a factor in the numerator and denominator that does cancel out, what's there?
0, a whole.
A whole. Or a removable discontinuity, or a point discontinuity. Point discontinuity. When the equation is in standard form, the blank, is the point 0c, where c is the quotient of the constant term of the numerator and denominator. Y-intercept. Everybody okay? Was any of that shocking or surprising to anyone? We did all this yesterday, so this is easy and good. Okay, so now one of the things that we haven't talked about as specifically is the horizontal asymptote. So we have dealt with our discontinuities, our vertical asymptotes, and our holes, but not really so much our horizontal asymptote. The good news is, it is super easy. There's no mathematics involved in the horizontal asymptote. The only thing that makes it hard is you just have to remember. So, we have seen that the graphs have horizontal asymptotes. Study the following equations and graphs and answer the questions that follow. And ultimately make 3 inferences about the existence of horizontal asymptotes. So we're going to see if we can figure it out just based upon looking at the equations. Okay, so in this case, again, it looks a little weird because your horizontal asymptote happens to be right on the axis, and so they went ahead and made the axis dotted. So both of these equations have a horizontal asymptote of 0. So look at the two functions. Since they both have an asymptote of 0, you might be looking for what they have in common. What's that?
They don't have an x squared in the numerator.
That's pretty important. They don't have an x squared in the numerator. Yes.
When you factor it all out, the top one has 1 factor and the bottom has 2.
The top one has 1 factor and the bottom has 2, which is sort of part of the same thing. Yes.
Numerator canceled. Like there's.
Will the numerator cancel on both of them?
I'm not sure.
I'm not either, actually.
It will on the second one.
Is it in relation to the x squared on bottom and the x on top, and how that's like a 1 to 2 ratio?
Yes. Yeah, y'all remember that from last year?
Kind
It has something to do with the relationship between the degree of the top and the degree of the bottom. So we all notice that this only has 1 factor on top, so it's x. It's a linear term, it's only 1x. where this is a quadratic term because there's two. So it has to do with the relationship between the two. Okay, so what do you notice about the degree of the numerator compared to the degree of the denominator? So how can we compare them?
It's
Mathematically, what's a good way to compare things?
1/2.
We could write it that way.
Factor it out.
One's lower, the top one's smaller.
How do you
than
write
the
that
bottom.
mathematically? One's lower than, one's smaller
Oh,
than.
Or greater than most.
Yeah, greater than and less than. So it's specifically talking about the degree. So I'm going to say the degree of the numerator is less than the degree of the denominator. And their horizontal asymptote is at the axis, which has the equation y equals 0. Okay, now these we haven't really talked about. But if you look at these two equations, these are still rational expressions, but they look different. And down here it asks, what do you notice about the degree of the numerator compared to the degree of the denominator? So let's go ahead and compare our degrees. In this case, the degree of the numerator
It's greater than.
is greater than the degree of the denominator. Then it asks the question, where does each function have a horizontal asymptote?
At 2x plus 4.
Y equals it.
Yeah, it's not
Y
here,
equals
it's type one.
A linear.
Oh, the bottom.
It's a linear equation.
Okay, wait. Real quick, let's go back to, I don't know, 3rd graders. Horizontal? What's horizontal look like?
Oh,
Asymptotes are shown on a graph with what kind of lines?
Linear.
Dotted lines. Does anybody see on these two graphs a dotted line like this?
No.
No. So where are the horizontal asymptotes?
they're
There aren't any. There's no horizontal asymptotes on these.
What is it? Diagonal.
Horizontal. No, there's no horizontal asymptote.
I was trying to find like a linear equation to it.
There's no vertical or
Now, is there a vertical asymptote?
yeah.
Yes. And there's another asymptote.
Slanted.
It is. It's called a slant asymptote. But it is not horizontal. So if the degree of the numerator on top is bigger than the degree of the numerator on bottom, there is no horizontal asymptote. There might be a slant asymptote, but not a horizontal. Okay. What do you notice about the degrees on these?
very equal.
They are equal. So the degree of the numerator is equal to the degree of the denominator. Alright, so let's look at the first one. Where is the horizontal asymptote?
Y
At
equals
2, y equals 2. What is the value of y equals a over b, where a is the lead coefficient of the numerator and b is the lead coefficient of the denominator?
It's 2 over 1.
2 over 1. Which is 2. So just in case you missed that, this is where we got our degrees, right? When I said, hey, compare the degree of the numerator and the degree of the denominator, you got them right here, right? This the highest exponent. So then this is asking for the lead coefficient that's connected to that x. So 2 over 1, which which just gives you 2, which is the same thing as the horizontal asymptote. Okay, so on this one, where is your horizontal asymptote? -1. And the value of A over B, so you're looking at your lead coefficient, so I found my degrees right here. You take these coefficients and put them on top of each other, so -2 over 2 would give you -1.
Wow. Adam.
Y'all remember doing that?
Yes.
We had a page called Tips to Finding Horizontal, and it was like a little flowchart thing. Okay, so based on all the information you see, here are the rules. If the degree of the numerator is less than the degree of the denominator, then the horizontal HA, the horizontal asymptote, I didn't want to write it all out, is y equals 0. If the degree of the numerator is greater than the degree of the denominator, there is no horizontal asymptote.
It should take long. Just talk on this road.
Okay, so like I said, there's no real math involved. So this is not difficult. The only thing that's difficult is to keep the 3 things straight in your head. Remember which one is which. Now, one of the things that you can do, if you think about it, we studied last year for several weeks the parent function of a rational expression, which is 1 over x. And we all know what that looks like, right? Where is the asymptote on the parent function? At the axis, right? At y equals 0. And what's the degree on top compared to the degree on bottom? What is the degree on top? Right, 0. And what's the degree on bottom?
1.
So the degree on top is less than the degree on bottom. So if you can remember that, that at least helps you remember number 1. And then the only thing you have to keep straight is 2 and 3. Trying to remember which one, okay, if it's greater or if they're equal. So, because you do have to know them.
Flashcards.
Yeah, flashcards are your friend. It would just be a shame to not know them and miss an easy question like that because you just forgot. So. Okay, so now let's talk about slant asymptotes, which we didn't really deal with slant asymptotes in algebra 2. So notice that this graph has a slant asymptote. This will always occur when the degree of the numerator is exactly 1 greater than the denominator. Now it doesn't matter what they are, it just has to be 1 greater. So if it's x cubed on top, it would be x squared on bottom. If it's x squared on top, it's just x on bottom. It has to just be separated by 1. So the degree on top is 1 greater than the degree on bottom. Notice the slant asymptotes are what we call oblique lines, just meaning slanted. Oblique lines are defined to be lines that are not vertical or horizontal. They have a slope and a y-intercept. from the graph, what is the equation of the slant asymptote? So this is just y equals mx plus b. They just want us to actually write this equation. So, looks like your y-intercept is 4. And looks like your slope is 1. So it would be y equals x plus 4. Is everybody okay? Welcome back to 9th grade. We're just over there. Write an equation of y equals mx plus b. Okay, so this is the equation for the entire function. If we were to plug this in our calculator, we would get this picture. It wouldn't have the dotted lines, but we would get these things right here. So they're asking us to synthetically divide the numerator by the denominator. So that's good, synthetic division, we like that. We're good at it. Synthetically divide, so coefficients, 1, 3, 2. In the box, I'm going to put positive 1. Remember, you have to solve it. So it's x minus 1 is a factor, but we're going to use 1. Okay.
Remainder 6.
With a remainder of 6. So I get, if I were to put this, so this was quadratic. So remember, when you synthetically divide, what you get is 1 down from that. So that makes this a linear equation. X plus 4, this is remainder 6. If you were writing it out, that would be y equals x plus 4, remainder 6. Y equals x plus 4 is the same as the slant asymptote. It should be. You just disregard the remainder. We're not really concerned about the remainder. All we're concerned about is the equation. So y equals x plus 4 is the slant asymptote. Just disregard the remainder. You just don't even concern yourself with it. Don't let it bother you that it has one. Don't worry about where you need to write it down. Doesn't matter. Alright, so let's do another one.
Wasn't that
Well, yeah, what, that was a
Did you
different.
write over another problem?
Oh, I thought it was the same one. Dang it!
Oh,
This goes
that's
here,
the
sorry. This actually goes right here in that little spot. Okay, let's do this one real quick. I'll do it in another color. Okay, so on this one, it's not as straightforward about what I'm supposed to divide with. Coefficients are easy. 1, negative 1, and 1. You can do this 2 ways on this. I can do 2x plus 2 equals 0 and solve it, or you can factor out a 2, and that will leave you x plus 1 inside the parentheses, which means you're going to put negative 1 in the box. You get the same one. Same thing either way. Is everybody okay on how you figure out what you're dividing by? Alright. Bless you.
So instead we divide by 2, we divide this one too.
Is this
Oh
one?
yeah, because I factored a 2 out. Yes. Yes. Hold on. Oh dang, I should have written right there. Oh well.
So you
Okay.
have to bring the 2 back.
Yes. So I did this, and so I used the negative 1. I can't, because of the slant asymptote, I can't disregard the fact that I factored out a 2. You can't forget about it. And remember, I've said that before about factors. Factors never go away. We can't just go, oh, they're all divisible by 2, and that factor just disappears. It doesn't ever really go away. So kind of like in bottoms up method, this 2 has to come back. And it comes back, it really comes back under all of them. But remember, we're disregarding the remainder, so we don't really care about this piece. So you're left with y equals 1/2 x minus 1, because 2 over 2 simplifies to 1. Now I'm going to go check and make sure that that actually is. Okay, so my y-intercept is at negative 1, and my slope is up 1 over 2. Do we have another one? Of course not. Darn it. At least we don't have one with a graph. Okay. Well, hold on, let's write down what we found. Okay, so based on what we just did, how do we find a slant asymptote?
Numerator, factor, denominator, and then
Divide the By the way, you don't have to use synthetic division. You can use long division if you like it better. It doesn't really matter. Synthetic division is just usually easier. So number 2, I'm just reminding you that if you factored something out, that means there was a lead coefficient, it's going to happen to us right here. These it won't. -1. But for sure on this one it will. If you factor that out, make sure you go back and divide by it. Okay, so let's do them. Now remember, it has to be separated by 1 degree. So in order to have a slant asymptote. And the degree on top has to be 1 bigger than the degree on bottom. So if I look at this one, the degree on top is 3, and what's the degree on bottom?
1.
That's separated by 2. So does this one have a slant asymptote?
No.
Does it have a horizontal asymptote?
Yes.
No.
No. No, it has none.
Has none. Because remember, if the degree on top is greater than the degree on bottom, is there a horizontal asymptote?
no, it's the,
No. So in this case, it is rational, but there's no horizontal asymptote, or at least we think it's rational. Maybe it's not. Maybe if we simplified everything out, stuff would cancel and it's not actually a rational expression at all. But it doesn't have a horizontal asymptote because the degree on top is greater than the degree on bottom. It doesn't have a slant asymptote either, which is what we're looking for. So no slant asymptote. What about g of x? Does it have a slant asymptote?
Yes.
It does, because the degree on top is 2 and the degree on bottom is 1. So we do have a slant asymptote, so we're going to synthetically divide. I'm going to put a -4 in the box.
No. 1/2 comes down.
Oh, gosh, thank you. I did this part right. My head is today. I don't know why. So y equals 1/2 x plus 3. Disregard the remainder. Everybody good? Okay. Okay, now look at the next one. It's in factored form, and I cannot synthetically divide with it in factored form. But before I worry about foiling it out, figure out if it's gonna have a slant asymptote first.
It will.
it will because the.
X times
two
X.
Yeah, exactly. Because I'm gonna do this x times I can get an x squared, and this is linear, so it's quadratic on top, linear on bottom. So they are separated by 1. So it will. So we do have to multiply it out. So let's do that real fast. Okay, so when I multiplied this out, I got all that, put it in order. This is what my fractional expression looks like. I went ahead and did this so that I'd know what to put in the box. I factored out a -1. That gave me x plus 1, which means when I finish, I'm going to have to divide by -1. It also means there's a -1 in the box because of this piece. So I got y equals 2x minus 1. Is everybody okay? I think that one, it was only a little confusing because there were a lot of ones involved. It will almost be easier if they were just numbers. Okay, will g of x have a slight asymptote?
Yes.
Yes. So same thing, I'm going to factor out a 2 so that I know what to put in the box. And that means I have to divide by 2. So I got y equals 1/2 x minus 7/2. Okay, now it's telling me to find the graph of the function, so to look at the graph of the function here, find the equation of the asymptotes, and draw them in on the graph. So in this case, you can tell by the way it looks that you definitely have a slant asymptote. I can tell by the equation, I have a slant asymptote. I also have a vertical asymptote. Do you have a horizontal asymptote? No. If you have a slant, you can't have a horizontal. So when they say asymptotes, they mean those two. I mean the vertical and the slant. So let's do slant first because that's what we've been doing. So I factored out a 3 on bottom so I would know what to put in the box. And that means I'm going to have to divide by 3 when I'm done with all this. Did y'all get 2/3 x plus 2/3? Okay, so now if I'm going to sketch that, obviously with a y-intercept of 2/3, that's kind of weird. We'll just do the best we can. Or, if you want to make your graph a little bit more accurate, you maybe could get it a little bit more accurate if you use x and y intercepts. Do you understand what I'm saying? So if I plug in 0 for x, I can find the y-intercept. If I plug in 0 for y, I can find the x-intercept, put those two dots and draw my line. Might be a little more accurate. And the reason I say that is because if I put my dot right here at 2/3, and then I have to count up 2/3 from that, everywhere I go is going to be a fraction. You know, it's kind of weird. Yeah,
It's not bad.
either way, you can do it either way. Doesn't matter. Okay, it looks kind of like that. Everybody okay? This one came out real nice, by the way. The x-intercept's 1, so put a dot there and put a dot 2/3. That's it. Okay, so now we need our vertical asymptote. Well, in this case, there is only one factor on bottom, and clearly there's a vertical asymptote, so you don't even have to worry about factoring the top and seeing if there's a hole and it cancels, because we know there's not one. So what's left on bottom is your vertical asymptote at -2. This right here. Everybody good? Alright, so now we're going to use the graph, look at it, and see if we can tell, answer some questions about it based on the graph that we see. No equation, just a graph. So, first question, what can be said about the degree of the numerator compared to the degree of the denominator?
Equal,
They are equal. How do you know that?
because they have a horizontal asymptote.
Good.
That's not the origin.
Good. Okay, and actually, my horizontal asymptote is at 1, right? So I know that this is y equals 1. That's going to help me with this next question. If a is the leading coefficient of the numerator and b is the leading coefficient of the denominator, what is the value of a over b? 1. Now, that doesn't necessarily tell us what a over b, what a and b are, but we do know they're the same, because that's the only way we could get 1. Okay, what factors can we guarantee are in our denominator?
X
And-
mod, or X plus 2.
X plus, okay, x equals 2 will definitely be there, which means as a factor it'll be written as x minus 2, right? X equals 2 as a whole. Where's your vertical asymptote? -1.
X minus 2 and x plus 1.
Yeah, so it should be x minus 2 and x plus 1. Remember, they come from the discontinuities. What factors guarantee be in the numerator of f of x that does not cancel out? And how do you know?
X plus 1 because it is the vertical asymptote.
Good. X plus 4.
X plus
Yeah, X plus 4 because that's the.
Yeah, x plus 4. sorry.
Yeah.
That's a 0.
Because it's the 0. Which factors guaranteed to be in both?
So, X minus.
X minus 2, because that's the whole. What's guaranteed to be in the denominator and not cancel
X
out?
X plus
X plus 1, that's the vertical asymptote. Okay, so in both factored and standard form, basically, you have all the information you need right there to write the factored form equation. You just go step by step. We know these two things are in the denominator. So, x minus 2, x plus 1. We know this is going to be in the numerator because that's a 0. We know x minus 2 is also going to be in the numerator because those are the removable discontinuities. So that that is f of x in factored form. In standard form, we just have to FOIL out the top and the bottom. It asks for two graphical reasons why your standard form equation makes sense. Two graphical reasons. First one,
Because it's
Degrees are equal.
the degrees are equal. And your HA is 1. And then I think the other good one is this right here. Negative 8 over negative 2 is 4, and that's your y-intercept. Now they did say write an equation. This is not necessarily the equation, because we could have different lead coefficients on this, and it wouldn't change any of the information. So